This is the find all numbers disappeared in an array problem. I want to go through two solutions that I came up with, and hopefully you guys can follow, and hopefully I can give you a different perspective of how I solved it compared to maybe how you thought of solving it. I'm doing this in JavaScript, and you guys can most likely follow it any other language. So this problem is pretty much we're given an array of integers where you have 1 as the minimum to n, from 1 to n, where n is the biggest one and n is the size of the array. So if you have a size of 8, that means it's 1 and the greatest number is 8. Some elements appear twice and others appear once. Find all the elements of 1 through 8 inclusive that do not appear in this array. Could you do it without extra space and in n runtime? You may assume that the return list does not count as extra space. So one of the things, especially an example, is here. We have 1 through n, where n is the size of an array. So that means that there's 8 items in this array, and we have from 1 all the way to 8, and we have to find all the elements that do not appear on this array. So we have 1, 2, 3, 4. We don't have 5. We don't have 6. We have 7, and we have 8. So the two numbers missing were 5 and 6. So that's pretty much our output. And one of the things we have to do is put that output. So one of the first things that I'm going to do here is especially when you start coding a lot, you do know that, or you get this intuition that using a map, you can have a key and a value pair. So that's the first thing that I thought of. I was like, you know what? I can have 4 and have that as, it came up once. I can have a 3. And that came up once. I have a 2. And that came up once. I have a 7. And they came up once. I have an 8 that came up once. I have a 2 that came up another time. I have a 3 that came up another time. Then I have a 1 and that came up another time. So use map and do this. And one thing that I then want to do is go through an array of 1 through 8, or 1 through nums.length, because nums is 1 through here from 0 to n, and n is the size of the array, so it's from 1 to 8, and go through each number. If it doesn't exist, add to an array. Which what I want to do is do 1. Does 1 exist? We're good. 2. Does 2 exist? We're good. 3. Does 3 exist? This number just has to exist. It doesn't matter what it is. 4. Does 4 exist? We're good. 5. See, 5 is not in this map. So since 5 doesn't exist, then we add 5 to that array. So that's the first thing that I thought of when I wanted this problem. And when you start doing more of these problems, you know that using a map, you can really, it's very, very powerful. You can have anything as a key and do any type of comparison, putting in the value. You can have an array as the value. You can have a string as a value. And you can, if I'm like, how many 4s are in here, you can use a map, put this as a key and, loop through this array once and put in that map all the 4s that come up. So using a map is very powerful, and probably one of all the data structures that you're going to use probably the most, I think, throughout a lot of LeetCode problems or all competitive programming problems in general. So this is the first thing that I thought of, just because I'm already comfortable with arrays, and I'm like, oh, I can put this in an array and just count the ones that are here. Or another approach, another solution that you can probably think of that is probably a little bit more for beginners, if you even want to, even though at this point it is not, I usually think about, oh, I could use the map, would be, to use a do like an n square solution, because this one right here is gonna give me an n solution, because I'm literally just gonna go through this loop once. Gonna do this for, or actually here, I'm gonna do it here, which is gonna be, give me that 4, 1, give me that 3, give me that 2, give me that 7. So it's just gonna go through this array n time, and then the next loop is gonna do n, is just gonna go through an array of 1 through 8. So I have 2 n's. But if you wanted to, you can probably do like an n square of, this like pseudocode of 1 through 8, and then do like from nums 0 to nums.length, and pretty much do 1. Is there a 1 in here? Then you're good. Then you're gonna do, like 1. Does num have 1? If it does, you're good. 2. Does nums have 2? It does. So then you're gonna get to 5. 5. Does nums have 5? If it doesn't, push to an array. So that's probably the first thing I would say intuitively that a lot of beginners would think of. So actually, this is my first solution. I even have a faster solution. I have is n, but it's actually because this is runtime. So this is the runtime n. All this is runtime. All this is runtime. And usually, if you're gonna create other arrays or more maps or stuff, then that increases the space time, complexity, and probably the next one I'm going to show you guys, it improves on the space time, even though I think the runtime is exactly the same. So as you can see, this is n squared. This is not even the first choice I thought of, but that's something you could have done. That's some pseudocode, but the first one I thought is this, and I'm going to implement this. And if anything, if you have any questions, let me know in the comments. So the first thing I'm going to do is, use a map. So I'm going to declare this maps. So declare map, which is let value equals new map. And then what I want to do is pretty much do this part. And a lot of times, when you do a lot of these codes, you can write base cases. So you can write if, the array is 1 or the array is 2. But here, I don't think we're going to have too many base cases. It just seems like it's going to be 1 to the n. I feel like my algorithm is going to do enough that it's not going to hurt the runtime right now. But, just in case you wanted to do that. But here, what I have pretty much is, I'm going to go let x in nums. So I want to go through every single value, 4, 3, 2, 7, 8, 2, 3, and this is obviously running n time. And I want to do, if my map has the number, then I want to add a value to it. So if it's 4, if it's already there, increase this by 1. Increase this by 1 if it's already there. Else, it hasn't been set. So set it. So this is the easiest one. So I'll do val.set num x. This is 1. So here what I'm doing is the first one is 4. So this is going to go through my for loop. The first one is 4. Is 4 in the map? No. So it's going to say else. Val set 4 to 1, just like I have here in line 13. The second one is 3. 3. Is 3 in my map? Nope. So I'm going to go right here, set it to 1. I'm actually going to change this out to 1. I'm going to do the same thing with 2. I'm going to do the same thing with 7. I'm going to do the same thing. I'm going to go to 8. Is 8 in my map? Nope. So then I'm going to set it here to, guess what? to 1. So the next value is actually a 2. So I have if value has 2, so as you can see here 2 already exists, then I just add another value to it. So what I can do here is value.set. I can set 2, which is the key, to whatever I already had in the map, and that's val.get nums 2. This is how you would do it in JavaScript. So val get nums 2, that's the value of 2 in that, which is technically 1, and I just want to add a 1 to this. So pretty much what this is going to do, and I can even console log it, or actually I could do a console.table of my map, is, as you can see, I have 4 has 1, 3 has 2, 2 has 2, 7 has 1, 8 has 1, and 1 time has 1. Guess what values are missing? 5 and 7. So what I can do, like I said here, is running n. I can go through an array of 1 through 8 or 1 through nums, and then go through each number. If it doesn't exist, add to array. So that's pretty much exactly what I'm going to do. So what I'm going to do is actually, and it says if it doesn't exist, add to an array. So I want to add an array right here of answers. So I'm going to do for let I equals I, or I equals 1, because I'm going to go from 1 to n. 1 to n, like it says here, is the size of the array. Actually, let me do this. I is less than or equal to nums.length, and it's equal to, because we're not doing like indexes or anything, is actually 1 through 8. Like I want 8. If not, this would have gone, people usually do like 0 to 7 because you're working with indexes, but this is I actually want 1 all the way to 8. And then I'll do if, the value, so if that 4 exists. So in JavaScript you usually do if it's a type, or if it exists or it doesn't exist. So this just means if the type, so this is going to get value of 1 and 1 exists. Then it's going to do get 2. So right here in line 13, 2 exists. Then here in line 33, get 3. And then 3 exists. Get 4, 4 exists. And then 5, but 5 doesn't exist, and 6 doesn't exist. So here I'll do ans.push I, because I want to push, this is the actual I is the key, which is the value missing. And then pretty much I'm just going to return that array with the missing values. And let me run it. And as you guys can see, success. Pretty much I increased my space time with this map and this pretty much array, and then my runtime pretty much is n, and this is n as well. And I wanted to do another solution that I thought was rather interesting, maybe a little bit more advanced, if you do guys want to stay and watch that. So one of the things that I want to do, remember here, actually go back where I have this map. I don't want to use a map or anything. Like I actually just want to use this same array. Like I want to reuse that array. So one of the things that and this took some time for me to actually think about, and I was like, what if I have this array of 4, 3, 2, 7, 8, 2, 3, 1. And the thing is that this is of index. I'm going to write the indexes of 0, 1, 2, 3, 4, 5, 5, 6, 7, 4, 3, 2. What did I say? 4, 3. I feel like I'm missing something. Okay, yeah, that's correct. So the top are my numbers and the bottom are my indexes. And what I said is, what if I can say, hey, let me turn nums into a positive to positive and negative numbers. And you're gonna understand why. Because if I have a 4 here, then I can make my fourth index positive. So actually, instead of these indexes, what I'm gonna do is do this. Hey, 4. My fourth index is available, so I'm gonna put that as actually as a negative. So that's 1, 2, 3, 4. So that's negative. And I'm actually gonna use 1 through 8 here. Then 3, that's my third index. So that's 0, that's 1, 2, 3. That's also negative. I have 2. 2 is my index, so 1, 2. So these are indexes minus 1. 7, that's minus 1, which is 6. 8 is here. 2 was already negative. 3 is already negative. 1 is already is negative. And then anything else is positive. So technically, what I can actually do is use this array again and just make these numbers positive or negative depending, on that index. So when I first go to 4, I'm gonna be like, oh, the fourth index, 1, 2, 3, 4. Then I'm gonna make -7 negative. Because later on, I'm gonna just go based on negative and positive. It's like a binary array that I'm creating. It might be a little bit confusing to understand and actually hard to even come up with, but obviously in computer science and in general, that's the whole point of algorithms and stuff. You can think of a lot of ways to do things. So what I'm gonna do and start off is the first thing I'm going to do is, loop through nums.length. So pretty much from 0 to 7, so 8 times, obviously. And that's n, pretty much, n time. But my space time is increasing. And as you can see, actually, I'm going to actually go to my submission and see how I had 44 and 5%. So I'm going to write this up to see how faster we get. 44% and 5%. And this is runtime. This is memory or space time. And that's the first solution. So what I want to do here is do for let I equals 0 is less than nums.length I plus and then what I want to do is pretty much put this negative in a sense. So what I'm going to do is I want to do, remember when I said these are indexes minus 1? So I want to use my numbers I, so 4 minus 1, which is the index, and then I want to make that 7, or the third. So once I know that 4 minus 1 is 3, then I want to make this number negative. So I want to make, I said if 4 and if it's positive, if the number is positive and I found it, then make it negative. Else, if not, then don't do anything. If found, turn negative. If not, do nothing. And one of the things also is that obviously if you have a number minus 1, usually we don't want if there's a negative, obviously things with the computers, I'm just gonna put absolute value. I don't really know if we need that, but I'll just put that for now. So this is pretty much gonna turn, let me console log that, console log nums. As you can see here, -4, -3, -2, -7, 8, 2, -3, -1. So that pretty much made my binary so I changed this own array, which pretty much I'm saying these are indexes. So 1, 2, 3, 4. See how this is 5 and 6 and they're positive? So all I have to do is go through nums, and once I go through nums, watch what I'm gonna do here. I'm gonna do if nums is positive, which equals to 0, then I wanna push my index plus 1, because remember here I subtracted by 1, so I'm gonna put plus 1 because that's the actual value. So if it's positive, so it's gonna go all the way through here, so 8 is positive, but I don't care about the 8, I care of where 8 is, and 8 is in 0, 1, 2, 3, 4 plus 1, which is 5, and 6, so this is gonna hold everything. And then all I have to do is return this this array here. I'm just gonna submit it. Just see, look at how much my solution improved. My runtime improved heavily just because I'm not using maps. Just manipulating that array file. I'm not looking necessarily anywhere in the map. And then my space-time, since I'm using this same array and manipulating it, not using a map, is also helping it. So look at how my first solution, my second solution improve substantially by doing it that way. And these are, there's many different ways to find these solutions, but you really have to think about it. So I'll leave you guys with that. If you guys have any questions, let me know. Thank you.